The next two examples, the first one is solving equations with multiplication involving complex numbers. So we want to solve x plus yi squared is equal to minus 18i. Let's look at expanding the left-hand side. How do we times two complex numbers together? Well, we have x plus yi times x plus yi. We do this just like for you. Do x times x, which is x squared, plus x times yi twice, so 2xyi, plus yi squared. Now, if I separate the last term, I have y squared plus I squared, but I squared is just -1. So we'll get x squared plus 2xyi plus y squared times -1. Y squared times -1 is just minus y squared. I'm going to rearrange this so the real part's in front and the imaginary part's later. So we have x squared minus y squared plus 2xyi. Let's put it back into our equation. So this should all equal. The right-hand side is, well, it's really the complex number 0 minus 18i. And I do that so I can see the real parts and the imaginary parts. Now, all we do is equate the real parts. From the left-hand side, we have x squared minus y squared as the real part. On the right-hand side, 0 is the real part. My imaginary part on the left-hand side is 2xy. My imaginary part on the right-hand side is minus 18. So let's equate. There should be no i's in the equations that you equate here. We have x squared minus y squared equals 0 for one equation, and 2xy equals minus 18 for the other equation. We can rearrange in both equations, perhaps making x the subject in the second equation here. And I get x equals minus 9 over y for that second equation when I rearrange it. If I let the first equation be equation 1, the second equation be equation 2, I'm going to sub equation 2 into equation 1. In this way, we'll get that, well, x squared, that will be minus 9 on y all squared equals to y squared, and I just rearranged for y. I'll end up with y to the power of 4 is equal to 81. Now, if you really think hard enough, I know that 3 to the power of 4 is 81. So then I can write 3 to the power of 4 equals y to the power of 4. But I also know that minus 3 to the power of 4 is also equal to 81, right? If you times a negative number by itself 4 times, you're going to get a positive number. So we have two options then. Y could be equal to 3 or y could be equal to -3. But because I have squares involved, I'm probably going to want to sub these answers into equation 2 so I don't get any plus or minuses and I rule out any extra or additional answers to the equations. If y is 3, x would be, so from equation 2, minus 9 over 3, which is minus 3. If y is minus 3, put it into that second equation, we'll get minus 9 over minus 3, which is just 3. So I get two solutions. Okay, last one here. We have z is equal to 5 minus 4i, and we've got to find 3 times the real part of z minus 2 times the imaginary part of z. First, highlight the real part and the imaginary part in your complex number. I know that the real part is just 5 and the imaginary part is just minus 4. Let's sub it into what we need to find. So make sure that your imaginary part is just the coefficient minus 4. Then we have 3 times, in brackets 5, minus 2 times the imaginary part was minus 4. And eventually when we simplify inside the brackets, we'll get 3 times 5 plus 13 because the two minuses will turn into a positive, and this will equal up as 39.